Hey everybody, Mr. Murray here, Mr. Murray's Mathland, and just a quick video to show you, remind you how to evaluate these common trig values at the benchmark angles without having to sketch the whole unit circle, if you'd like. If you like sketching the unit circle, be my guest. But remember, everything that has the same reference angle has those same basic coordinates. The only thing that changes is whether they're positive or negative, and that depends on the quadrants. So remember, that's one of the things you'll want to consider. All students take calculus or add sugar to coffee, whatever, a smart trig class. Those tell you which functions are positive in which quadrants, ASTC. So everything's positive in quadrant 1, sine and its reciprocal, cosecant, positive in quadrant 2, tangent and cotangent in quadrant 3, cosine and its reciprocal of secant, positive in quadrant 4. Okay, so the basic reference angles come down to, remember here's the deal with the chart, 30, 45, 60 in ascending order, which is pi over 6, pi over 4, pi over 3. Sine, cosine, tangent. I only do the 3 basic ones because if I need the reciprocal ones, I'll just flip it. But some kids will draw out 3 more rows for cosecant, secant, and cotangent. They feel it's worth it to draw it and have those values there. Totally fine. So remember the deal, sine and cosine, for all 3 of these, all have one thing in common. They're all over 2, over 2, over 2, over 2, over 2. And their numerators are root 1, 2, 3, right in order. Root 1, which is 1, root 2, root 3, and then count it back for the cosine. Root 1, root 2, root 3. For your tangent, you can do sine divided by cosine. So you cancel those 2's, and 1 divided by root 3 gives you root 3 over 3 for pi over 6. Root 2 divided by root 2 is 1. Root 3 divided by 1 is root 3. And there you go. You get the values pretty quickly. Now it's just about reference angles and quadrants. So sine of 7 pi over 6. Sine of 7 pi over 6. The reference angle, this is why I love radians. I don't really even need to worry about, I know the reference angle is a pi over 6. It's just which quadrant is it in. And 7 pi over 6, that's quadrant 3. Remember the benchmark angles have those nice patterns where if it's 1 more than the numerator, or sorry, 1 more than the denominator, it's quadrant 3. You know, that's a 7 pi over 6, 5 pi over 4, 4 pi over 3. And so I'm talking about sine of 7 pi over 6. It's going to have the same basic ratio as sine of pi over 6. Sine of pi over 6 is 1/2. So it's going to be 1/2. But I'm in quadrant 3. So you just got to ask yourself in quadrant 3, the only thing positive is tangent in quadrant 3. So my answer is negative. Reference angle will tell you the basic ratio, and the quadrant tells you whether to make it positive or negative. That's it. Those are the only 2 things you need. So cosecant of 5 pi over 3. Love radians because I know the reference angle is pi over 3. 5 pi over 3, that's quadrant 4. You know, the pattern there in the quadrant 4 is double the denominator minus 1. So cosecant of 5 pi over 3, that's the reciprocal of sine. So the sine of pi over 3 is root 3 over 2. So the reciprocal of root 3 over 2 is 2 over root 3, which rationalizes to 2 root 3 over 3. And we're in quadrant 4, where only cosine is positive. So sine, and therefore cosecant, is negative. Negative 2 root 3 over 3. Tangent of 5 pi over 4. The reference angle is pi over 4. We're in quadrant 3. Again, you can spot that quickly if you don't know them yet. The numerator is 1 more than the denominator, 5 pi over 4. That's quadrant 3. And the tangent of any pi over 4, tangent of any pi over 4 is 1. And in quadrant 3, tangent is positive, so we leave it as positive 1. There we go. Now I do some degree examples. I actually prefer radians. You might also, or you might learn to. 315, if you have to visualize that, that's quadrant 4. And the reference angle is how many degrees away from the x-axis are you, right? The nearest x-axis, and that's 360 minus 315. That's 45 degrees. So I can treat this the same way as I've been doing. The reference angle is 45, and the cosine of 45 is root 2 over 2. And I'm in quadrant 4 where cosine is positive. So I leave this as positive root 2 over 2. Secant of 270, hey, 270, that is a quadrantal angle. So when you're right on one of the axes, on the y-axis or on the x-axis, the quadrantal angles, 0, 90, 180, 270, 360, etc., that's where I really think you want to think about the coordinates of the circle, and you're 1 unit straight down, so that is 0, negative 1. Secant is the reciprocal of cosine. So remember, x before y, c before s. Cosine is the x-coordinate, sine is the y-coordinate. So the secant of 270 is 1 over the cosine of 270, or the reciprocal of cosine of 270, however you want to say it, and that is 1 over 0, and 1 over 0 is undefined, does not exist, whatever you want to say there. So the secant of 270 is not defined. And this problem right here should be numbered 6, sorry about that. Cotangent of 120. Cotangent of 120, you are in quadrant 2. What is your reference angle? How far away from the nearest x-axis are you? That's what we're talking about there. That is 60 degrees, right? 180 minus 120, 60 degrees. So I'm just going to think about the cotangent of 60 degrees being in quadrant 2. Cotangent of 60, well, that's the reciprocal of tangent of 60. The tangent of 60 is root 3. What's the reciprocal of root 3? 1 over root 3, which is root 3 over 3, right? Remember, these two are reciprocals of each other, so you flip one, you get the other. And in quadrant 2, only sine and, cosecant are positive, so tangent, cotangent, everything else is negative. So negative root 3 over 3. So hopefully just showing you a few examples, gives you a chance to rewind if you like. But think about it. Maybe you prefer to do it with triangles, or like I said, sketching the whole circle. But whatever it takes to be able to pull these values out, and hopefully at random times, even throughout this year, you might need to know what's the sine of 5 pi over 6. You want to be able to find a method that works for you to kind of quickly refresh yourself on these values to get them without a calculator. I mean, that's really the goal there. Okay, so if you have any questions, just let me know. Have a good day.